know you're on the right page if the holes for your paper are on the left-hand side. Okay, I'm going to do number 2. I'm going to unzoom this just a little bit so we can get a little better in here. Okay, your $780 investment sees interest at 7.5%, which is compounded monthly for 7 years. What is your total investment worth plus interest after 7 years? So how much did we initially start with, guys?
780.
Okay, good. And my rate is 1 plus 0.075. And I know that because it says, what's my total investment worth plus the interest? Okay, now I know it's 7 years, but it's compounded monthly. How many months are in a year?
12.
So we're going to have to go 7 times 12 up here. Okay, so we can put that in our calculator. And we're going to get,
2.029.
let's try that again. Hold on. 780 parentheses 1.075. Raise it to 7 times 12. Make sure they're all up in the exponent.
339,000.
That is correct, and that's dollars. Make sure you put the dollar sign.
I typed it in the same.
Okay, so let's look. Hold on, I'm going to clear this. Shh. Hold on one second. We're going to type it into the calculator. So here's my calculator. Okay, trying to get it so you can't see too much of a glare. We had 780, right? Then you put parentheses 1.075, or you could put 1 plus 0.075, same thing. Then you must take it up to a power. You can't times it. It's got to raise up to that exponent. 7 times 12. They both have to be up there. Then you hit enter. Okay? So I think some of you were going, raising it to the 7th and then timesing it by 12 or doing something a little bit different. Okay?
I don't understand this calculator.
Okay. So now we're going to do number 4 unless there are more questions. Okay, let's look at number 4. I'm going to zoom it back out. There we go. We're going to look at number 4. The $10,000 you borrowed for your car cost you an interest rate of 5.6% compounded annually. What does annually mean? Each year, right. For 2 years. What did you pay for your car in total after 2 years? So we start with 10,000. 1 plus 0.056 squared to the 2. And we get, no, because it's compounded yearly, not monthly, right? That was a great question. So she said, why aren't we timesing this one by 12? Because you're doing it yearly, not monthly. Nolan, what did you get for your answer? Why don't you plug it into your calculator? So we're plugging in 10,000, right?
2, 4, 3, 3, 6.
No. Try it again. You plugged in 10,000. Count the number of zeros. You should have just 4 zeros. Parentheses. 1 plus 0.056. And then raise it to the 2. Did you do 0.56 instead of 0?
Yeah.
0.056? Okay, can you fix it?
I will.
Okay. What'd you get?
1115.
You got $11,151.40. Okay, should I do another one? Okay, let's do 6. Okay, you invest. Maybe we should do 5 because it looks a little funky. Okay, your 3.5-year investment of $1,830 with an interest of 14%, which was compounded quarterly, is worth how much after 3.5 years? So we started with 1,830, correct? We're going to say 1 plus 0.14, correct? Okay, now here's the issue, the time. Compounded quarterly means it's done how many times a year? 4. Okay, 4 times a year. So 3 times 4 gives us, so it's got to be like 3.5 times 4, or you could say 1,830 times 1.14, and 3 times 4 is 12, plus half a year means 2 more, so we should get 14. Does that make sense how I figured that out? Okay, so 3 years, 4 times each 3 years, how much? 12, right? And then we have a half a year. So how many times, if we compound something quarterly, how many times does it happen in half a year? Twice. So we've got 12, 13, 14. Yeah? Okay, let's put in our calculator. 1,830 times 1.14 to the 14, or 3.5 times 4. And I should get 11,458.3. How are we feeling? Okay. The back of this sheet is your homework. You do not have to do the front. The back will be your homework. We are going to move to your next worksheet. And we're going to do these notes on compounding continuously. Okay? What if we want to compound continuously? Then we use E, which is useful for describing continuous growth or decay. This is a natural base exponential function. Okay? So when we go into logarithms, this is important, that the natural base. Okay? E is a number like pi. Okay? If we took our calculator and we pushed E, which is, it's right here is E, and then took it to the first power, we would end up with 2.7182. It's like an irrational number like pi. Goes on forever. Okay? So, A is the actual amount at t time. P is the principal, which is what I begin with. R is the interest rate. T is the time, and E is just a number. So, we're going to go through these 3 examples, labeling all of them, and then sticking it into the equation, P, E, to the RT. Okay. So, if a $500 certificate of deposit earns 4.25% compounded continuously, then how much will be accumulated at the end of a 3-year period? Okay, so P is my initial amount. So that's 500. Rate is 0.0425, and the time is 3 years, right? Yeah. Okay, so we're going to put this in the equation. We're going to write P, which is 500, E, R, which is 0.0425, times 3. And then we're simply going to put that in our calculator. And this all equals A. So A equals $567.99. 99.2, or so 99 cents. We'll just stop it there. Questions about that? Okay, why don't you guys try to set up the equation for example 2? Okay, what did we get for P, guys, for number 2? 10,000, good. What's our rate? And what's time? Good. So we're just going to go A equals 10,000 E 0.0875 times 5, and we get A equals 30 cents. Yep, 15,488. Okay, example 3, and then we're done. We start with 20,000. We have 0.06%, and we're going to do it for 100 years. Okay? Because if we invest $20,000 at 6% annual interest compounded continuously for, say, 2 generations or 100 years, how much will our family have accumulated? So we're going to go 20,000 is our P times E to the 0.06 times 100. Okay? And you should get some crazy number. So I want you guys to try putting that in your equation right now and see what you get.
What?
Did you get something like 8.06858 e to the
Yes.
7th? Okay. So if you get something like 8.06858 e to the 7th, I think it is? 6. Okay, it means you need to move your decimal point over 6 places. If this was a negative, it would be the opposite way. So I'm going to move it over 1, 2, 3, 4, 5. So I'm just going to add a 0 at the end to move it over 6. So it's $8,068,580.
I wish I had that much money.
Yes, if you could find some sort of investment where you could, it was compounded continuously, and you had $20,000 of it. Think about your grandchildren and great grandchildren would be millionaires. Okay, so this is the homework again. These 5 questions on the back, and the back of your compound interest, those 10. So you have 15 that you've got to do.